We've already covered some of the things that we can do with PCs today that we didn't do. But if we were to look ahead, what do you think that we're going to be doing with personal computers? And I mean, from that, you know, your machines here are somewhere between a workstation and a personal computer. What do you think that we'll be able to do with this field called personal computing, where you are in control,
Sure.
that we can't do today?
Well, what's happening right now with our industry is it's bifurcating. All current generation personal computers, all IBM PCs, most of the current Macintoshes are all going to go portable. They're all going to be smaller, all portable. Within 2-3 years, everything will be portable. And yet, customers are also demanding at the same time more power. And more power falls into 3 or 4 areas. People want large color screens that they can put photographs on. Ask anyone in the upper part of desktop publishing as an example. People want motion video. People want to be networked with very high-speed networking, at least Ethernet speeds. And people want to be sending all of this rich media around the network. Unfortunately, this second class of product cannot be made portable. So what I see is our industry bifurcating, where the current generation of products are going to be portable, and the next generation of products, these very powerful, highly networked color machines, are going to be desktop machines. And that's where I think we're going. Now, what is going to be the new breakthrough that causes the next spurt of growth in our industry? Just like spreadsheets did in the early 80s, desktop publishing did in the late 80s. And again, I come back to interpersonal computing. I think personal computing, which we mastered in the 80s, its mission was to improve individual productivity and at best creativity. And with over 50 million personal computers shipped in the 80s, it worked. The next thing for the 90s, though, needs to be more. Improving individual productivity isn't enough anymore. The real competitive advantage in the 90s is going to come from improving group productivity and collaboration. Improving group productivity. And that is going to be achieved through interpersonal computing, using the same desktop tool that revolutionized analysis and planning with spreadsheets, that revolutionized publishing with desktop publishing, using those same tools to revolutionize human-to-human communication, collaboration, and group productivity. And I think that is going to be the third revolution of the desktop computer in the first half of the 90s.
Are you a fan of Lotus Notes?
I think we're about 3 or 4 years ahead of that kind of thing with Next now. That's why a lot of people are buying our stuff. We have something that's
Way
pretty
beyond
remarkable,
that.
yeah. So Lotus Notes is okay, but it starts off with a PC, so you have a lot of the inherent limitations.
Did you have any idea early on, say early 70s, the late 70s, early 80s, that the PC was going to have such a dramatic impact on the entire structure of the computer industry?
Sure. Again, what's hard to remember is that by 1979, when we were at Apple, we were already shipping more computers measured in units than IBM was. Remember, IBM was only shipping big mainframes and a few attempts at mini computers. We were already shipping more computers in unit volume in 1979 than IBM was. So the thought occurred to us, certainly by then, that this was going to have a staggering effect because of the unit volume.
If we're going to come back to you in 5 years for the 15th anniversary of the PC, what among the companies that are out there now do you think may well go away, and which amongst them that are, somewhere in the also-ran pack do you think may be running up front?
Well,
besides Next.
Let me correct I think a mistaken impression that you articulated. I don't think this is the 10th anniversary of the PC. I think it's the 15th anniversary of the PC, or maybe the 14th, because the first modern PC as we know it appeared in 1977, and it was the Apple II. And the Apple II sold 5 or 6 million units until it was retired. And IBM entered the PC business with their products, which turned out to have a very large effect. But nonetheless, there was, the course had already been plotted in 1981. So I think it's the 10th anniversary of IBM's entrance into the PC market. 5 years from now, let me answer a broader question than that, and I'll come back to that one,
Okay.
at the risk of wasting some of your videotape.
That's all right. The tape is cheap.
There's a constant tension in our industry between standards and innovation. And I think it's a healthy tension. Standards are very good because they give everybody a baseline. They give everybody a low-cost economic vehicle. But left to themselves, people that usually are the standard bearers don't have any incentive to move forward, and ultimately customers lose. And that's the role of the companies that innovate. Companies that innovate use as many of the standards as they can, but then leap up from them and try to provide new opportunities through innovation, with a certain amount of risk associated because they're not part of the standard. And some of them succeed very wildly. Macintosh, as an example, was a real step. It was a real revolution versus just an evolution. As where most of the things in the PC world have been evolutionary. 286 to 386 to 486. Excuse me.
Sometimes.
And it's this tension between the evolution and the revolution that I think keeps our industry moving forward. We've seen 7 years after Macintosh, finally the IBM world is getting some of the graphical user interface that was available in 1984 with the Macintosh. So this evolution-revolution tension, I think, is extremely important to keep on going in the future. And the revolutionaries that manage to establish a critical mass, get up to a certain size before the evolutionary people catch up, they survive and prosper. Those that don't get absorbed into the evolutionary path. And with that perspective, when I look at what is happening now, unfortunately, I see a lot more status quo in the next 5 years than I see real evolution. I don't see much coming from things like the Apple-IBM relationship. I see more of the same coming from Apple over the next 5 years. I see more of the same coming from IBM in small evolutionary steps, 286s to 386s to 486s to 586s, but nothing really different. Spreadsheets will run a little faster, but nothing really different. I see, System 7, System 8, System 9 coming from Apple, but fundamentally, nothing really different. And I wish I saw more. But I think it's going to be up to some of the other companies like Next and others to provide that revolution in the next 5 years, which, 5, 6, 7 years from now, the standard bearers can catch up to, just like we saw the PC world catch up to Macintosh 7 years later.
Let me ask you something that may
I can say that more articulately if you want me to.
Well, no,
yeah.
I think that covers really well. One of the questions I have, I saw the Xerox Star system over a decade ago, I guess it was, with document context architecture.
Mm-hmm.
Why hasn't the personal computer developed along those lines until really the Go operating system, where you can touch and essentially be doing the spreadsheet in one document, touch, and then you're doing graphics in the same document without having to open new applications and so on. I mean, I know that the power wasn't there initially, but now it is.
Well, I guess I take exception to a lot of your contentions. The Star didn't actually do that quite. The Star actually opened separate applications. The industry's wrestling right now with compound document architecture. And Go made a sort of very simple attempt at it, but unfortunately one that I think will not be robust enough for real-life use. And it's a very difficult problem. It's actually more of a user interface problem, I think, than anything else. It's very difficult because, as an example, when you use a spreadsheet, there's a lot of paraphernalia that goes with the spreadsheet, maybe a little bar so you can type in things and a few buttons. And when you use a drawing program, maybe there's a palette of things that sometimes is even glued right onto the document. So how do you handle the context switches from a user interface point of view when you move around through these various sort of objects in your document? Nobody's yet figured that out. The underpinning technology It's very easy to hack up now and give a demo of, but to really do it right, you'll see some things next year. So I think, and Star also didn't really solve the general problem. Remember that all the applications on Star were written by Xerox.
Oh, I know. I mean,
So-
I didn't want to get into the
Yeah.
whole question of what they did wrong in that.
No,
I
no,
was just
the point I'm trying to make is it's very easy to do something when you write all the applications, because then every application can know about every other one. And in general, a company turns out 5 or 6 applications and they all know about each other, and you can give a great demo with these apps. But the real key is to come up with an underlying structure that will let third parties who never talk to each other have these capabilities within their apps. And no one's yet done that. No one has yet done that well. And I think you'll see some of that next year.
how much. One of the pieces that we're doing is going to be about as much as we ever get into things like personalities.
Uh-huh.
So let me just ask you, looking back from the day that you guys came up with the notion for Apple One, how much has your life changed, and how has it changed?
Well, for me, that's a really big subject because my whole adult life has been spent building personal computers. We started Apple when I was, 20 years old, and I'm now an old man of the industry at 36. So I've been doing this for about 16 years, and it's been my whole adult life. So the history of my vocation and my avocations and my growing up are all the same. And it's very hard to separate one from the other.
All right.
You see what I'm getting at?
I see what you're getting
yeah.
at. Is there anything that we haven't touched on in the course of running through all this stuff that you'd like to get to, either in terms of the narrow issues or the broad brushstrokes?
Well, I think there's two interesting issues that you could touch upon. One is, of course, the American versus Japanese issue, and the second is that our industry. Some people think our industry is very mature, and they think there's going to be rapid consolidation and very few companies left over, and it's pretty much very predictable from here on out. Which is that point of view I do not share at all. I think we're about 1 inch down a road that's many miles long, and that every time there's major technological innovation, there's a tremendous opportunity for new players, for a reorganization of the industry to occur. And I think that there is certainly as much opportunity for innovation in the next 5 years as any 5-year period I've ever seen in our industry. And I think there's just as much opportunity for new companies to come along, for new approaches to be taken, and for customers to get much better computers 5 years from now than they have today. So I'm pretty optimistic. And I think we all need to remember that we're just in the infancy of this revolution. And it will continue to occur throughout our lifetimes. And I hope and I work with a group of people that all work very hard to make sure that the rate of innovation doesn't slow down, and that most of that innovation continues to come out of the United States of America.
All right. You have a take on the U.S.-Japanese thing?
Well, yeah, I do. As we look at the types of computers we're building today and projecting in the next few years, a disturbing fact is that even though most of the computers are assembled here in the United States, a significantly large number of the dollars that one pays for the components of those computers, to build those computers, flows overseas. The most expensive part of many computers is the display, whether it be a color cathode ray tube or whether it be a flat panel display. And almost all of those dollars flow to Japan. One of the second most expensive component in most computers is the dynamic memory. And again, most of those dollars flow to Japan. The third most expensive component is the hard disk drives. And most of those dollars flow to US companies, even though the disk drives are mostly built in Singapore. And one of the things I think we need to keep our eye on the ball of is to manage those most expensive components back to America. And I think that that's going to take some real effort, especially in the display and the DRAM area. It's going to take some effort because those are capital-intensive products. The factories to build displays or DRAM are now costing $500 million to $1 billion a piece. And the engineering required is also something that one doesn't build up overnight. But it's, I think, essential that we don't continue to be hollowed out as an industry, where even though the assembly of the final products, the printing of the manuals, the bow on the shipping carton gets tied here in the U.S., most of the dollars don't get sent across the shores.
You're in a very fortunate position because you are privately held, and you don't have to worry about the quarter-to-quarter problems that some of your publicly traded brethren have to worry about. How much of what you're talking about is a result not so much of the advances being made by the Japanese, but by the impediments that exist in the American capital structure in terms of investment disincentives for long-term capital holdings, in terms of the quarterly outlook of the Wall Street analysts and so on?
Well, I don't really buy that argument, and let me give you some reasons why. If I'm going to build a factory and it's going to cost $100 million, that factory doesn't get written off the minute I build it. That factory is an asset on my books, just like cash in the bank is. It gets depreciated over many, many, many years. So that decision to build that factory doesn't really affect my earnings statement. It affects my balance sheet because I take $100 million of cash and put it into a $100 million factory. But it doesn't affect my earnings and shouldn't affect what Wall Street views are my prospects or my results. And I think that the real problem has not been with Wall Street, it's been with the management of our industry. It's been with people not being willing to take responsibility for the underlying component technologies and thinking that we could give that responsibility to others and survive in just as successful of a fashion, which is not true. Industry after industry has shown us that that's not true. So we have to have more accountability for our raw technologies and not just assume that we can be the final packager at the end, because ultimately the providers of those components don't need the final packager at the end. Ultimately they can go directly to the consumer. And they have relationships with the consumer already, as Sony does and others in Japan.
I mean, so Sony, the builder of the next Apple portable, next Mac portable?
Ask John Scully.
I'm going to.
So I don't really think saying it's Wall Street is too easy. We've got Apple, we've got IBM, and many other computer companies with hundreds of millions, if not billions of dollars in the bank in cash. Raising the capital is not the problem, and Wall Street is not the problem. The problem is that in many cases the management of our companies is not from an engineering or manufacturing background anymore, and may not appreciate the dependence we have on these underlying technologies. Is where if you go to Japan, the people running these companies are engineers or they're from the manufacturing backgrounds, and they very much appreciate.
Is that why U.S. Memories failed?
I don't know. I don't know anything about U.S. Memories.
That was the
yeah, I know.
Yeah. All right, I think that pretty much covers.
Good. Thanks.
Excuse us, Steve.